There are other ways to find least common multiple too. We're going to look at finding the least common multiple by prime factorization. Every number can be made by multiplying a set of prime numbers together. This is known as prime factorization, which we've learned about in another lesson. We find the prime factorization of a number by dividing out prime numbers one at a time. Let's do a little review of finding the prime factorization of a number. We're going to use the number 200 and break it down to its prime factorization so that we remember how to do this. So we begin by dividing out prime numbers one at a time, and we start with our least prime numbers, 2, 3, 5, and see if those numbers are divisible for the number that we're working on. So in this case, I have the number 200, which is an even number and tells me, because it's even, that I can divide it by 2 and break it down to 2, which is a prime number, and another number. So 200 divided by 2 equals 100, or 2 times 100 equals 200. So I break it down the first branch, or the first level, just once by dividing out the prime number 2. Now, since 2 is a prime number, I leave it alone, but I do want to include it on my next level of this pyramid. So I leave my 2, but then I need to start working on my 100 and see, first of all, if it's divisible by 2. If it's not, then I move up to 3 and up to 5. But in this case, 100 is divisible by 2. So I do 100 divided by 2, which equals 50. And I break this 100 down into 2 times 50. Now, since 2 and 2 are prime numbers, I'm going to leave them on my next level of the pyramid and just focus in on working on breaking down the 50 to its prime factorization. So again, 50 is an even number divisible by 2, so I can do 50 divided by 2 equals 2 times 25 and break down the 50 into 2 times 25. Okay, now on my next level, I am going to leave these 3 2's as they are because they are all prime numbers, and my goal is to get a level of my pyramid with all prime numbers. So I leave my 2, 2, and 2, and now I have a 25 to look at. Now 25 is not an even number, so I know that it's not divisible by 2, and so I move up to my next prime number, which is 3, and ask myself, is 25 divisible by 3? No, it's not. So I move up to my next prime number, which is 5. Is 25 divisible by 5? Yes, 25 is divisible by 5. 25 divided by 5 equals 5, or 5 times 5 equals 25. So now, when I've gotten to this level of the pyramid, where all my numbers are prime numbers, 2, 2, 2, 5, and 5, I know that I'm finished with my prime factorization. The prime factorization then of 200 equals 2 times 2 times 2 times 5 times 5. I'll put a square around that since we have a lot of work up here on the board. And I can see then my prime factorization of 200 broken down to all the factors in their prime numbers. Let's take a look at an example of finding the least common multiple of 3 numbers using prime factorization. So we have a problem here that asks us to find the least common multiple of 8, 12, and 18. So first what we want to do is find the prime factorization for each of our 3 numbers. So let's begin with 8. 8 is an even number, and so I know right away that I can divide it by 2. And so I ask if the number is divisible by 2. Yes, it is. 8 divided by 2 equals 4, or 2 times 4 equals 8. 4 is not a prime number, so I'm not finished yet. I need to break 4 down into its prime number factorization. Since 2 is a prime number, I leave it alone and set it over here, and then I work on breaking down the 4. 4 is an even number, and so it's divisible by 2, and we know that 4 divided by 2 equals 2, or 2 times 2 equals 4. So I can put my 2 2's here. So I can see that I'm finished now because this level of my pyramid has all prime numbers. So the prime factorization of 8 is 2 times 2 times 2. Let's break 12 down into its prime factorization. 12 is also an even number, and so it's divisible by 2. 12 divided by 2 equals 6. So I can break my 12 down into 2 times 6. 6 can still be broken down. 6 is not a prime number. And so I will leave my 2 here. Should make a line here so we don't get these too confused. So I'll keep my 2 here, which is a prime number, and I'll work on breaking down the 6 for this next level. 6 is an even number, divisible by 2. 6 divided by 2 equals 3, or 2 times 3 equals 6. So now I have 3 prime numbers, 2, 2, and 3, and so I know I'm finished. The prime factorization of 12 equals 2 times 2 times 3. Let's look then at 18. So again, we have another even number. 18 is an even number, so it's divisible by 2, and I know that 18 divided by 2 equals 9, or 2 times 9 equals 18. 2 is prime, so I leave it alone over here on my next level of the pyramid, and I now want to break down the 9. Here we come to our first not even number, or our first odd number, and so I know that 9 is not divisible by 2, and so I move up to my next prime number, which is 3, and ask myself, is 9 divisible by 3? Yes. 9 divided by 3 equals 3, or 3 times 3 equals 9. And so again, I'm finished with my prime factorization because all the numbers in this level of my pyramid are primes. Now, what we're going to do in order to find the least common multiple is that we are going to combine the prime factors into one set by using each of the prime factors. So we have 2's and 3's. We're going to use each of the prime factors the greatest number of times that it is found in any one of our numbers. So let's first look at the 2. So 2 is one of our prime numbers, and we want to find which of these sets, or which of these prime factorizations, contains the greatest number of 2's. So our 8 has 3 2's. Our 12 only has 2 2's, and our 18 only has 1 2. So we are going to choose for the 2's this set that has the greatest number, which is 3 2's. So we begin by going 2 times 2 times 2. So we are working on finding the least common multiple now. So we have our greatest number of 2's that we put here, 2 times 2 times 2, 3 of them. And now we move on to looking at our 3's. So that's the other prime number that we have in our set. Now, there are no 3's over here in the 8. There's 1 3 in the 12 prime factorization, and there are 2 3's in the prime factorization of 18. And so we are going to use 2 3's in our least common multiple in our set. So now we bring these 2 3's over, and this is our combination of prime numbers, of prime factors that we've put into one set by using each of the prime factors the greatest number of times that it appears in any of our numbers. And so that is what I need to multiply together now to find my least common multiple. And I can see in this set that it does contain each one of my numbers. If you look at the 2 times 2 times 2 here, we've got our 8. If you look at the 2 times 2 times 3, we have 12. And you look at the 2 times 3 times 3, we have 18. And so now we multiply this all together. 2 times 2 times 2 equals 8. 3 times 3 equals 9. 8 times 9 equals 72. And so our least common multiple of 8, 12, and 18, by using the method of prime factorization, using prime factorization to find our answer, the least common multiple of 8, 12, and 18 is 72. Let's take a look at the other method of listing out the multiples of 8, the multiples of 12, and the multiples of 18, and finding if they have any in common, and then the least of those common multiples. I've listed out the multiples of 8, and I see that I have the 72 that we found. It's also in the multiples of 12. And 72 is also found in my multiples of 18. And if I look back on the smaller numbers, there are no smaller numbers that these three have in common. And so 72 is my least common multiple.